Welcome to my new video. Now I will show you how to compile a PLM program in the ISX2 emulator in CPM. CPM is running on a C80 CPU on my self-built computer, and it has 64 kilobytes of RAM, and it emulates two hard drives with 8 megabytes each and one floppy drive with 256 kilobytes. I've prepared a simple PLM program that interfaces with BDOS, and I'll show it to you. Type so drives in ISIS are F0 till F3 if you have 4 drives. So drive C equals F2, and I've prepared a simple program called my.plm. And one thing you have to take care about is that CPM does only size files by sectors. This means that the file size has to be a multiple of 128 bytes. Otherwise, the ISIS emulator will get garbage in the end of the file, because ISIS wants the file size in bytes and not aligned to a sector boundary. So this program first defines a boot procedure, which is external. So this has to link against some other file, an assembler file that defines the location of boot. So this is the simple boot vector. And mon1 is BDOS entry point. And then we can define a print procedure that calls mon1 with a function code of 9 and an address. And in the main program here we call print together with a string, and the string ends with a $sign, and the monitor function, so the BDOS function number 9 will print this string until the $sign, and so the address of this data string is given into A, and mon1 is called with a function code 9, and this one calls the BDOS interface. Some of you might also remember DOS now, because DOS has copied this function number 9 to print strings like all other functions. So we will now compile the program. F2 PLM 80 F2 my.plm, and now the PLM compiler will start, and this will take some time. The CPU is running with 2 MHz, and although the file is very small, it takes some time to write the listing onto the disks. They're actually emulated with a compact flash card here. This is the CPU board. It should now soon be finished. Come on. Yeah, you can see on a modern CPU this would take fractions of a second. Now it's done. Now we got an object file, and we have to link this object file. So F2 link F2 my.object, comma. So we specify several object modules with comma. And now I have the system interface os5tr.object. This is just a compiled assembler source file that defines the monitor mon1, and I also don't know why I call it monitor. Actually, it doesn't make sense. But mon1, what should it be? So to F2 And this is a locate table file. That's not the final file. So this is a moderate step, and the files are usually called mod. So my.mod, and this should now link. And now you have to locate the relocate table mod file. F2 locate, F2 my.mod, and you tell it the code entry point like so, 100h, stack size 100. Oops. By the way, rub out is Control H. Stack size 100. Enter. And this will produce a relocated file, which is just called my, without any extension. And to finally get the program, we type F2 and we make a hex file. Object to hex my to my dot hex. Yeah, I forgot the drive. F2 object hex F2 my to F2 my dot x. Finally, we got the hex file, and now we can quit the ISX simulator. Now we got back to the A prompt, and here we have the standard load program of CP/M, and we can use it to load C. Remember, F2 was the C drive. My.hex. We can load it into memory. And this generated a my com on drive C, hopefully. There is it, my com. So we started my.com. Sorry. You don't type extensions. And here we go. So the program worked. So it's a very time-consuming process to compile, link, relocate, and generate the program. Yeah. Just value modern CPUs and modern programming languages. Thanks for watching.